All right, we're on number 4 now. How many integers n satisfy this inequality? All right, it's a fourth degree polynomial inequality. So let's go to the whiteboard, and I'll write that down. And it's a familiar question. I'll say that's an inequality. And you got n is an integer. I know that much. So it's an integer. I just don't know what the integers are, though, for this. So it's n4 plus 6n less than 6n cubed plus n squared. Well, the first thing I do is solve for 0. When I say solve for 0, it's an inequality, so I get one side equal to 0. So it's going to be n4 minus 6n cubed plus n, not plus n squared. Let me go backwards on that. Minus n squared plus 6n less than 0. All I did was I subtracted 6n cubed from both sides and n cubed from both sides. I'm going to try to factor by grouping. So I'm going to say n cubed, and you get n minus 6. I'm going to factor an n over here, and you get n minus 6. Well, that's kind of working out. What do you have there? N minus 6, and then n cubed minus n. Well, you know, I can still factor that, can't I? And what do you get? You get n minus 6. I'm factoring an n out from this guy over here. And you're left with an n squared minus 1. All right, I can still factor that. What do you get? n minus 6, n minus 1, n plus 1, less than 0. The number line goes down. This nonlinear inequality, I'll put the zeros down. One of the zeros would be n is equal to 0. The other one will be where n is equal to 6. The other one will be n equals 1. And the other one is n equals minus 1. All right? What did you test the intervals out? And a good place to start, I would say, is a number after 6, which would be 7. What's a good number after 7? I'm sorry, after 6 is 7 or 8 or 9 or 10. Plug it in. You get positive, 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 positive. So everything here is positive, which are not less than 0, so that's not going to be shaded in. Let's go between 1 and 6, and a good test number to pick would be 5. So if you put a 5 down there, what do you get? You get positive. Let's write this down for you. I'm using the factors, by the way. That's a factor, that's a factor, that's a factor, that's a factor. Positive, negative, positive, positive. Overall, it's negative. This definitely satisfies the inequality as less than 0. What's a good number between 0 and 1? Half. If you plugged it in, what would you get? Positive, negative. Let's see, negative, and a positive. Overall is positive. It may seem ridiculous doing this because they're integers, but I still want to go through it. Minus 1/2. Plug it in. What do you get? Negative, 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 and then you get a positive. Overall, that's going to be negative. Let's go below minus 1. A good number below minus 1 to choose. Oh, by the way, negatives are satisfied the inequality. I'll shade that in. A good number below minus 1, like minus 2, and plug it in. What do you get? Negative, 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 and a negative. Overall, multiply that out, you get a positive, which are not less than 0. So there's only 2 intervals that satisfy this. Now, if this was a real value inequality, I would just simply say, oh, minus 1 to 0, union 1 to 6. But this is asking for the integers. So what are the integers over here? By the way, there's no integers between minus 1 and 0, but there are integers between 1 and 6. And what are those integers going to be? 2, 3, 4, and 5. Let me go back to the question and read it to you again. How many integers? How many integers? There's 4 integers that satisfy that inequality. Only 4. 1, 2, 3, 4. And we're done. Thank you.